Hi, good morning, everyone. Welcome to GS 215, which is the pre-anatomy and physiology. It's sort of like a continuation of GS 182, but the focus is more on the human bodies in this course. As you might know, right, anatomy means the names of the various structures in the body, and physiology is about how they work, right? So, for those of you who are planning to go on to nursing programs, for example, they would actually have the anatomy and physiology course as well. That one is much more in depth than what we have here, and they have a healthcare focus in that course. But this particular course is going to give you the foundation and lay the groundwork for you so that you will be successful when you take a more advanced version of this. So, like I said earlier, I think a lot of you had me for last semester. And if you did, the format is very, very similar. And for some of you who might be new, welcome to the class. And I'm just going to go through some of the basic things that are posted on eCentennial to help you navigate, where to get your notes and the course schedule and things like that. If you do have any questions, please either unmute yourself or just post in the chat room, and I'll address them accordingly. So the course page is up, as you know. Let me switch to the student view so it looks exactly like what you would see. Every week, I'm going to post announcement, okay, either at the beginning of the week or after each class. I will tell you that the recordings are available, the notes are available, and I'll give you links for you to click on. Right? Anything that's blue, you can click on it, and it will take you directly to the page that I am referring to. Just like last semester, there are no textbooks for this course. We are using the same open source textbooks. But again, those tend to have extra information that you are not responsible for when it comes to tests and quizzes. You will only need to know the things that I teach you in class, things that are in the PowerPoint slides, as well as the study guides. Okay. Now, if you go to content, I saw that many of you have had a chance to look at it. You will see Unit 1 is up. Okay? So let me take this opportunity to explain to you the structure of the course. We will have 3 units in this course. Okay? So Unit 1, there's going to be 4 lectures, Lecture 1 to Lecture 4. Okay, Unit 2, which is not available yet. Okay, I'll post them later on. There's no need to go too far ahead. Okay, it's going to be 5 to 8, and then for Unit 3, it is going to be number 9 to 12. Okay, so a total of 12 lectures, which is more than what you had last semester. Last semester we had 10. And our meeting times, of course, is longer as well, right? It's 6 hours per week, as opposed to, what was it, like 4 hours per week in semester 1, right? So we meet every Monday, Wednesday, 8:30 to around 11. Okay, I'm not going to go all the way to 11:20. Okay, so it's just around 11. And of course, the lectures are going to be recorded. They will become available online after class. But it's best that you come to class, right? Like in terms of difficulty, if I'm being honest, this course is significantly more difficult than the previous one because of the content, as well as the amount of material. Okay, so there are more things to remember, and the things that you need to remember and the things that you need to learn are more complicated to understand. Okay, so those two things makes the course a little bit more difficult, but it's never unfair, right? Like if you took my quizzes last semester, like the quizzes are based on the things that we learn in class. And you're welcome to use your notes again, right? Like during an online environment, but you just have to have the physical copy, right? If you took the online course, you will know that many of us use the lockdown browser, so you will not have access to websites or digital version of your notes while taking the test. But it's okay to use the physical notes, right? In fact, I encourage you to have your notes like a summary sheet right next to you, same as last semester for my course. Okay, so each unit you will have a 10% quiz, and the quiz is just going to be the first lecture. Okay, so again, 10% quiz here, which is lecture 5, 10% quiz, which is lecture 9. Okay. And you will have a 20% test, right, which does not include the first lecture. Okay, so only 3 lectures for the test. Right? That way is easier, right? Less things to worry about. Okay, so same thing for the other one. I'm not going to write it out. Okay, 20% for Unit 2, Lecture 6 to 8, so on and so forth. Right?
Teka lo form mi padà, mi ò gbọ́ dáadáa mi báyìí.
Sorry. Oh, I think you unmute yourself accidentally, Tohib, or did you have a question? Oh, that's okay. Okay. And then there's going to be a lab. Okay, a lab. 2.5% lab. I'll explain more what that is. Okay, we call it a lab quiz. Okay, 2.5% lab quiz here as well. And then the lab quiz for the last unit is 5%. Okay, because it's like there's more stuff to know in the end. So if you add it all up, that's going to be like 30%, 30%, and then 30%. That's 90%, and then that's 10%. So that's where you get the 100%. Right? So it's a lot more broken down. There's less things to worry about per test, per assessment, okay, rather than like 5, 6 lectures at the same time. Any questions about the way that the course is broken down into? Okay, that's good. So go back to here. In the content, you will have access to all the lectures in Unit 1, 1 to 4. And it's the same stuff, right? You have the PowerPoint slides. If you are printing it at home, I made it 6 slides per page this time, so it saves you ink and paper, right, and printing costs. And then there is the study resources, which includes supplementary readings, as well as where is my study guide? Let me go to the actual folders here. Oh, did I not? Oh, there it is. Okay, so under the study resources, there is going to be the study guide. And it's a little bit different this semester. Okay, like last semester, I know we didn't use the study guide too much during class. It's more for you to do it on your own afterwards. But in this course, we use it quite a bit in class, right? Because there's a lot of diagrams, a lot of labelings that we have to do. So I do strongly recommend that you print it out and have it ready, okay, during class. Crosswords, self-quiz, internet video resources that you can use, okay? And then because we'll be learning a lot of body parts, it's very useful to use these coloring sheets I found to practice when you have a chance. So if you click on these things, for example, you will see diagrams, and then the answers are usually at the bottom. Okay, these are additional diagrams that we're not doing in class, but you can use them for the purpose of practicing. Okay, so these are very good sheets. And again, all these is going to be under the study resources in each of the folders. Okay, so that's lecture 1. Lecture 2, same thing. You will have study resources. I'm not sure why it's not showing up on the side, but if you go into it, right, you will see that, right? Study guide, so on and so forth. Okay. Now, the labs, I'll explain more when we get closer to it. But it's different from last semester again. The labs, you just have to go through these PowerPoints slide yourself. I think they're available right now. So you click on online lab. It's probably best that you download it onto your computer and do it yourself. So there will be models. Like if this was in-person class, you would be like actually holding the model, examining it, discussing it with your classmates. But in an online situation, you just look at the diagram here, and then it will ask you questions about the model, right? So label A, B, C, and D. So like, okay, A here. I mean, if you don't know what it is, that's okay. We will learn it today, right? You write down the answer. A is aorta. Okay, B is pulmonary artery, so on and so forth. And you just go through the PowerPoints yourself. Okay, some of them has videos in it. And you watch it, and you just do this. You don't have to hand this in. Okay, you do not have to hand this in. This is for your own for you to keep yourself the answers. Okay, and then when you're ready, when you finish doing this, you will go and take the lab quiz. Okay? So if you go to assessment and you click on quizzes, these are all self quizzes that you can do, right? They are not worth anything. But then there is a lab quiz, right? That's going to be due February 7. It's not available yet because like you're not going to do it now, right? Like you have to do the lab first. The lab is the PowerPoint slides, right? You go through them, you find the answers, and then you take the lab quiz. Okay, so the lab quiz is typically due right before the unit test. Okay, so it gives you a little bit of marks and it helps you review for the test as well. Okay, and the questions are based on the slides that you've done in the virtual lab. Okay, now together, each one is like 2.5, 2.5, right? And then the last one is 5%. It doesn't sound like a lot, but it adds up to 10%, right? And I structure it in a way that you can do the lab quiz 2 times, and it will only record your best grades. So if you do it the first time, you get 75. You study more, you try again, and then you get 80, right? Or 90, right? Then the marks that are being recorded will be the 90%. Okay, so 2 attempts, the highest score is the one that counts. Statistically speaking, most people get over 95 on these lab quizzes, if not 100. Okay, so they're basically like free marks. Okay, you just have to go through the work and get that extra 10% to cushion your grade a little bit, right? Any questions about the structure of the lab? Okay, great. Now, if you go back to content, there are other important information like the useful resources here. There's a link to the tutorial recordings. I mean, I can click on it and show you. It's nothing right now because I haven't uploaded anything, but at the end of each class, this will get updated, right? So it's good for you to bookmark this and have it easily accessible. There's the course outline, which you can download a copy for you to use in the future. Right? If you go to another program and they also have something similar to this course, you can show it to them, and maybe you don't have to take it anymore. You don't have to take it one more time. I mean, the weekly schedule is important. Okay, even though the course outline gives you like week by week topical, we go by the weekly schedule. Okay, because it's like we have to take into account things like the engagement week, the family day, and stuff like that, right? So you download this, and this is the schedule that we're going to be going by, right? Typically, we can do 1 body system per week. Okay? Each lecture is about a body system, right? But we'll see. If we need to adjust the test dates and stuff like that, I will let you know. But our first quiz is going to be Monday, January 22nd. In terms of the quiz format, it's the same as last semester. You will have the period is 6 a.m. in the morning until 11:59 p.m. You can take the quiz, the test anytime during that window. The questions will be combination of multiple choice, multi-select question, which are questions with more than one correct answers, as well as some application questions. Okay. There are no written response question in this course. Okay, so make sure you download the schedule, and you will have to come to class when there is a quiz, but no class when there is a test. Okay, quiz you have to come to class. And I think that's pretty much it for now. Okay, anyone have any questions before we get started with the actual lecture?
Excuse me, sir.
Yeah, go ahead, please.
I was unable to find the link on InCentinel.
You cannot find the link.
Yes.
You
So
mean
I had to go to the email, but I couldn't find it here on InCentinel.
You mean the course homepage?
Yes.
Okay, I just put it
I
in the
mean
chat box.
the link to this class.
Okay.
It's not on InCentinel.
I just put the link in the chat box. Could you take a look if that's if you can access it? Let me see if you're actually in my class. Yeah, you're here, and I see that you're online.
Yes. Because I was actually saying that I did not see it when I wanted to log in. I had to go to my email, not on this on this page you are.
Okay, but you're able to access it now, though, right?
Yes.
Okay, that's wonderful. Yeah, I'm not sure. Sometimes the system, maybe is a little bit glitchy. But yeah, if you guys find any broken links in the website, or if you are unable to access something, just let me know. Okay, because I copied the shell from an old course, right? Like from the previous semester, right? So sometimes when it copies over, some links become inactive, and some notes becomes missing. It's just like some kind of glitch in the system. You just let me know. Okay, just email me. Okay, anything else you guys want to ask me before we start? I hope you've downloaded the notes. Okay, so here we go. Oops, this is not showing up here. Give me a second, okay? Now, I cannot stress the importance of coming to class, all right? But I think you guys are pretty good, okay? You are looking at the names, you are the people who actually came to class every week last semester. So I'm not too worried, but I hope we can keep it up, okay? Because we do a lot of things every class, and watching the recording is just not the same, okay? It's just not exactly the same. All right, so our first unit, we will talk about 4 different systems, right? Starting with the cardiovascular system. They're not arranged in any particular order. I try to put the easiest stuff earlier on in the course, and then the more difficult stuff come later on. If you go and take this course somewhere else, they probably will do it in some other order. It doesn't really matter. But the first lecture is cardiovascular system, which talks about the heart. And then we will talk about blood in the second lecture, followed by the immune system in number 3. And finally, we will talk about the respiratory system. Okay, so that's your first unit right there. Okay. So let's start by talking about the major components of the cardiovascular system. Of course, the heart is going to be the key component of the cardiovascular system. It provides the driving force for blood circulation. every time the heart squeezes, it is going to send blood away from the heart, and then the blood is going to go through various blood vessels before returning to the heart. Now, in humans, we have what's called a closed two-circuit circulatory system. Close means the blood stays inside blood vessels. Okay. It might sound very obvious, right? Like it's hard for us to imagine why would the blood not be in the blood vessels? Like that's just like bleeding all over the place, right? But actually, in other organisms, like insects, for example, it's common for them to have what's called like an open circulatory system. Instead of having blood vessels that distribute the blood is kind of like a pool, and then the cells are just kind of bathing in it to get the nutrients. Okay, so you know it exists. It's not very it's not uncommon actually. Okay, but for us, we have a closed circulatory system. Okay, the blood stays inside the blood vessels at all times. And we also have what's called a two-circuit circulatory system. So let's take a quick note here and you know, do make big diagrams. We're going to come back to this diagram throughout the course, and we're going to add details to it as we progress. So this is class notes, January 8th. Okay. So let's talk about what it's like to have a one circuit circulatory system. There we go. So things like fish, okay, fish, they have a one circuit circulatory system. They have the heart. Okay. They will pump the blood to a structure for gas exchange. Fish do not have lungs. What do they have instead for gas exchange? Can anybody tell me?
Gills.
That's right. They have the gills. It's going to go to the gills. And then it's going to go to the body. And then the blood is going to come back to the heart. Okay. The major disadvantage of this is that after the blood passes through the gills, the pressure and the speed will drop a lot. Okay. And then it takes a long time for it to pass through the body. It's not a big deal for the fish because fish, they are cold-blooded. Right? They don't maintain a constant body temperature. So even though the circulation is slow, but it suits their purpose. Okay. This will not work in a human. In a human, we are warm-blooded. We have to maintain a constant body temperature of 37 degrees Celsius. And because we're much bigger in general compared to, you know, small fishes, we need to have constant fast circulation to meet the needs of the body. So that's why we have the two circuit. And again, please draw these big because we are going to add details to it. Two circuit circulatory system. So we have, I'm going to put it in the center right here. We have the heart. And we're going to send the blood.
Excuse me, sir.
Yes.
I missed something. You told about a speed create heart to body, body to heart. Could you explain again?
Sure. So after the blood passes through the gills, the pressure of the blood is reduced and the speed of the blood is also reduced. Okay, so now the blood is going slower and slower and slower. It doesn't pass through the fish body quickly, but that's okay because the size of the fish and the fact that they are not warm-blooded, they're cold-blooded, they're not going to be affected by it. Okay, this, even though it's slow and even though the pressure is low, it's adequate for the need of their body. Okay, is that the part that you missed?
Yes, okay, I got it.
Okay, perfect.
Thank you.
Yeah, let me know if you have a follow-up question later. So for us, the heart is gonna beat and it's gonna send the blood to the lungs where you pick up oxygen, right? It does more than that. We'll talk more about later. But instead of going through the body right away, it's gonna come back to the heart. And the heart is gonna give it a second squeeze, and then it's gonna go to the body before coming back to the heart. So that second squeeze is gonna fix the problem of the one circuit circulatory system, right? It's gonna give it pressure and then it's gonna give it speed, right? So with the high pressure and the high speed, it's gonna be able to go through the entire body before returning to the heart again. So this here, that's one circuit, and that's the second circuit. All right, these circuits have names, but we will add to this later on. Okay, for now, just have this thing handy next to you. We're gonna add more details to it as they become available in the slides. All right, so humans, closed two-circuit circulatory system. Of course, I'll post the notes after as well. So don't worry if you are not able to copy everything down in time. Now, the vessels that are passing through the body, we have two main ones. Okay, we have the arteries and we have the veins. Okay, arteries, they move blood away from the heart. That's how you can remember. Okay, artery equals away from the heart. It always starts with A. There is a misconception, okay? Perhaps because of how people learned it before, or you might have read something about it. There is a misconception that arteries and veins are defined by what's within them and what kind of blood they carry, but that's not true. Okay? Arteries and veins are defined by whether they carry blood away from the heart or they're returning blood to the heart. If it's sending blood away from the heart, it's an artery. If it's bringing blood back to the heart, then it's going to be called a vein. Okay, so basically it goes like this. Okay, heart, and then you have an artery, really big, typically big, and then it's going to become a smaller version called arterial, and then it becomes the smallest blood vessel, capillary, and then it joins to form the venule, and then vein, and then back to the heart. Okay. So the difference between arteries and arterial is that the arterial are smaller. Think of artery as a highway. Okay, arterial would be more like a regular street.
Can you just move the bottom bit up a little bit? I can't see it.
Oh, unfortunately, I cannot move. I cannot move stuff on the PowerPoint, but I guess I can write it here again. Okay. So heart, artery, arterial, capillary, venule, vein, and then back to the heart. Okay.
excuse me.
Yeah.
Venule is a very teeny to artery, yeah?
So artery is big, okay?
It beginning as from heart to artery to venule.
Mhm.
It's like a teeny, and teeniest venule.
Okay, good. Okay, so this is the smallest, tiniest, okay, smallest.
Oh,
Yeah. And then the capillaries come back together to form the veins, and then form the venules, and then venules get bigger and bigger and becomes the vein. All right. So in this direction is smaller, 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 smallest, and then bigger, 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 biggest. Okay? As you're returning to the heart, right? As you go back to the heart, they get bigger and bigger. Good question. Okay, Madison,
thank
you
you.
good? You good with this thing now? Can I move back?
Yes, thank you.
All right. So we have lots of blood vessels in the body. In fact, no single cell is more than 2 cells away from a blood vessel. Right? If it's too far away, it's not going to be able to get the nutrients right from the blood. So if you have a paper cut, for example, you've damaged a capillary. Okay, sometimes people have like a little bit of a red eye, and that's the capillary in the eye bursting, right? And it can happen when people have like high blood pressure, for example. Right? So like blood vessels everywhere. But here is a list of key blood vessels that I want you to know. So for example, going up to the head is obviously very important. Right? We have what's called the carotid artery that takes blood to the brain, and then we have the jugular vein that returns the blood back to the heart. If you put your 2 fingers in your neck here and you press lightly, you can feel the pulse of your carotid artery. And we'll talk about what a pulse is later. But do you know we do not take the pulse with the thumb? We never take a pulse with the thumb. Does anybody know why?
The thumb has a heartbeat you can feel.
That's right. The thumb has its own pulse. Yeah, so you're gonna get confused. And you don't know if you're counting the person's pulse, you're counting your own pulse, right? So we can use other fingers to feel the pulse and carotid artery going up. There was a story I read on online where a person was going into the salon to get her hair done, right? So washing hair, getting her hair washed, right? But the angle of the chair was not positioned properly. So her head was tilted back a little bit too far, and she actually compressed her carotid artery without knowing it. So she got a stroke, at the barber because of the chair. So something like that is, of course, quite scary. There are other vessels here. Right? We have the brachial artery and the brachial veins. That's the one that goes down your hand. Lungs, we have the pulmonary artery and pulmonary veins. The word pulmonary has to do with lungs. Anytime you hear the word pulmonary, you know you're talking about the lungs. Right? So more on that later. We have the coronary arteries and the veins for the heart. Renal means kidney, and then hepatic for the liver. Okay. It seems like a lot of words here, but as we progress through the course, right, these things would make more sense. And you heard of like hepatitis, right? Hepatitis is the inflammation of the liver. So HEPA, right, has to do with the liver. Okay, not the filter, right? I guess it's kind of similar, right? The liver is like filtering things for you. Okay, but now I want you to focus on this one, the lung, right? We take the blood to the heart through the pulmonary artery, and we're gonna return the blood to the heart through the pulmonary veins. So if you have this diagram here, what should I put over here? The heart is sending the blood to the lungs. What vessel should I put on this side?
The pulmonary artery.
That's right. Very good.
Pulmonary.
That's the pulmonary artery. A for away from the heart. And then when we are ready, when we have picked up the oxygen, we're going to send those blood back to the heart through the pulmonary vein. Pulmonary artery takes it to the lungs, pulmonary veins, send them back. Okay. So, you know, we'll come back to some of these later, but these are some of the majors one that you have to know. So where is the heart, right? I mean, of course, we know where the heart is. Most people say it's to the left of the body, right? But it's actually a little bit centered, but slightly to the left. It's not like completely to the left, right? It lies in the thoracic cavity. We learned about the thoracic cavity last semester at the end, right? That's basically where your chest is. And it's beneath the sternum. Okay, so your sternum is right here. Okay, if you press down from here, you feel like a hard bone, and it goes down here, and then it ends in a notch. And this is your sternum. It's also called the breastbone, I think. Yeah, sternum. And then the heart is between the lungs. You have two lungs, right? Of course. The heart is a little bit pointy at the end. We call that pointy part the apex. Okay. The pointy end of the heart. And it lies on the diaphragm. And remember, the diaphragm is a muscle that sits right here, is usually dome shape. It helps us breathe. And the diaphragm separates the thoracic cavity from the abdominal cavity, right? There's a diaphragm right here. So the apex, the pointy part of the heart, just kind of lies on the diaphragm. And it points to the left side of the body. The heart is surrounded and protected by a membrane called the pericardium. Okay. And you know, at this point, you probably feel like, oh, there are a lot of new terms, right? And which is why those crosswords that are on the eCentennial is going to be helpful. Okay, to fill in the blanks, right? You might want to do cue cards to help you remember it. So this pericardium, it's a double layer sac that surrounds the heart. It keeps it in place because the heart moves all the time. It keeps on beating. You don't want it to be jumping all over the place in your thoracic cavity. So you want to protect it. You want to anchor it. That's what the pericardium is for. More on that later. And then there's going to be a little bit of fat, right? And all major organs is going to have a bit of fat surrounding them. Right? We learned that fats are important for insulation, right? Keeping them warm, as well as cushioning, right? And protection. They are like bubble wraps.
Excuse me.
Yeah.
In fact, function of pericardium held heart, health. Yeah.
How does it
Hold heart.
oh, how does it hold it in place?
Yeah.
Yeah. So
This
it
function for.
That's right. So it wraps around the heart, and then it's basically serve as a type of connective tissue, right? We learned about connective tissue.
Yeah.
Right? So it sticks it to the chest wall, basically. Okay, as you will see, and that holds it in place. It's like a cling wrap. So there, that's the actual heart. I don't know who came up with the idea that we should draw hearts like that. The heart looks nothing like that. Okay, as you can see, this is the real thing, and that's the apex right there. Apex. And it's important to know when we are looking at a diagram like this, we are looking at it from the front. This is an anterior view. Okay, so it's like you're looking at you're looking at my lungs, for example, looking at my heart. Okay, so on the page, the right side of the diagram is actually the left side of the structure. Okay, and you have to be cognizant about that. right? Because when you label things on a diagram, you have to put right and left, right? So make sure you know if you're looking at it from the front, if you're looking at it from an anterior view, the right is the left and the left is the right. Okay? So there's the heart. There is the apex again, and it's pointing to the left side of the body, and you have the diaphragm right here. Okay, the diaphragm is again the muscle that helps you breathe, and you can see the halo that goes around the heart. This thing right here, that is the pericardium. Okay? It keeps it in place, it protects it, and as you will see, it prevents the heart from rubbing against the lungs, right? We don't want organs to be rubbing against each other. It could create friction and increase wearing and tearing. So over here, we can see the heart has these gooey stuff on it. That's the fat. You can kind of see some of these blood vessels right here, like maybe some of these right here. Okay, that's the coronary artery, right? That we saw earlier, right here, right? Says the heart has the coronary artery. Right? We'll learn more about that later. But you know, if someone has a heart attack, it's their coronary arteries that gets blocked, right? Okay, I'm just gonna pause for a second. Anybody have any questions?
Diaphragm is like fats or bone or what it is?
The diaphragm?
Yeah.
Diaphragm is muscle. Yeah, muscle. It's a breathing muscle, right? Okay. When we have hiccups, like hiccups, right? The diaphragm is like moving up and down, like involuntarily. Okay, but when we breathe, right, we use the diaphragm. Okay, so it's a muscle. It's skeletal muscle. You can control it.
Sir, I have a question.
Mm-hmm.
The pericardium,
Mm-hmm.
the double layered sac, does that consist of fat as well?
That is connective tissue. Connective tissue, so not fat.
Okay.
Yeah. Okay, let's move on. Now this next part is confusing. Okay. But let's try to understand it by drawing it. Right? So we'll talk about the heart wall. Heart wall. Okay. Now we'll talk more about this later. Okay. Even though I just make fun of people who draw the heart like this, but I'm gonna draw it like that. Okay. Did you know the heart has 4 chambers in it? And there are 4 empty chambers in it. Okay. 4 empty chambers. We'll talk more about it in a second. But this is where the blood is going to be going. The blood is going to be, you know, filling up these chambers. Okay. So that's like the blood. Okay, and these empty spaces, they are chambers of the heart. And what I want you to focus on right now is take a slice here, and then we're gonna zoom in. All right, so let's recap. The heart has chambers filled with blood. We're gonna take a look at a section here. All right. So let me make it bigger. This is where the blood is. The blood. Just stop me if I'm not making sense. Okay, this part is confusing. Blood. Okay. So, and you need a lot of colors in this course. Okay, we're gonna be using a lot of colors. I will recommend markers more than crayons, because markers you can color over each other. So over here, we have a layer in the heart wall that is in direct contact with the blood. That is the innermost layer of the heart wall. We call that the endocardium. Okay, endocardium. epicardium, the innermost layer of the heart wall. The heart wall is what makes up the wall of the heart, right? That's literally what it means. Now, this layer needs to be smooth. Blood does not like to pass through a rough patch. Anytime blood passes through a rough patch, it has a tendency to clot, and you know, we don't want blood to be clotting in the heart or in blood vessels, right? The only time we want blood to clot is if we have a cut. We want to stop bleeding. Okay, so to make sure that the blood don't clog up unintentionally, we want to create a smooth layer, and so the endocardium is made up of simple squamous epithelium. Okay, now we learned this last semester, right? Remember simple squamous? Can someone remind me what simple squamous means? How many layers for simple? Yes, thank you, Blessing. One layer. And squamous means what kind of shape? Is it cube shaped, rectangular shape, flat? Like what is it?
Flat.
That's right. So we have a single layer of flat cells that makes up the endocardium. Okay? And it's good to be that way because we want it to be smooth, right? All right, I hope that makes sense. Now on the outside, okay, we have another layer. Okay? This layer is perhaps the most confusing layer. Let's just label it first. This is called the epicardium. Okay, it's the outermost layer of the heart. Okay, both the endocardium and the epicardium, they are relatively thin. And the right over here in the middle, that's the muscle of the heart. Okay, we call that the myocardium. Okay, it's the muscle. Okay, it's the thickest part of the heart wall. Are we okay so far with this diagram? Because I'm about to add something that might confuse you, but I want to just triple check that you guys are good with this. All right. Remember we talked about the pericardium? The pericardium is the double layer sac that goes around the heart, right? So I didn't draw the pericardium here, but let me do that right now. Okay, so like this thing that goes around the heart. I mean, this is not to scale, okay? But this yellow thing that goes around the heart, that would be the pericardium. Okay, and it has two layers, right? Double sac. The best way to visualize this is I don't have any props here, but like imagine, you know, taking the heart model, and then you put one plus. Yeah.
Oh, sorry. Is the
That's right.
pericardium among the four chambers of the heart?
Is the pericardium sorry, say it again.
Is the pericardium among the four chambers of the heart?
It's outside, surrounds the whole heart.
Like, is it part of the chambers?
No, the chamber is this is the chamber, right? This is the chamber. Chamber is inside the heart. Okay.
Oh, okay.
All right. So just this is not entirely accurate, but think of having a heart model, and then you put it inside a Ziploc bag, and then you put it inside another Ziploc bag. So you have two layers, right? Okay. So why is it confusing? Well, it's confusing because of this. Now, let me try to draw this for you. Okay. This is going to be the pericardium. Okay? Pericardium. Okay? Now that's the outer layer of the pericardium, which we call the parietal. Parietal pericardium. And then there is the inner layer of the pericardium, which actually is the same thing as the epicardium. So also forms the visceral pericardium. Okay. So this green thing right here, the green thing represents two things at the same time. It's the outermost part of the heart wall, but is the inner layer of the pericardium as well. Okay, there are two things that represent two different structures, but it's the same thing basically. Okay, so all these things here, I'll put a star here. The endocardium, this thing, and this thing. Okay, those are the heart wall. And then this here, a different color star, and this here, that forms the pericardium. Okay. Now there are some fluid that is inside, in between the two layers of the pericardium, okay, which is right here. There's some fluid right here. And this fluid is called the pericardial fluid, okay, which reduces friction.
Professor, can you explain again parietal and pericardium?
Say that one more time, please. I missed the question. Sorry. What was it?
What is parietal and relation between parietal and pericardium?
Okay, so the pericardium has two layers, the outer layer and the inner layer. Outer, we call it parietal. The inner layer, we call it visceral. Okay, and this is a common theme that you will see. Many organs will have a double layer membrane. The outer one is always called the parietal. The inner one is always called the visceral. Okay.
Excuse me, what?
The what? The second? The inner?
The inner is the visceral.
Sorry, can you spell the visceral?
Right here. Visceral.
Okay, yeah, thank you.
Mm-hmm.
Excuse me, I'm thinking about the function of pericardial fluid. It's work like a lubricant, like a oil.
Exactly, yeah. It's a lubricant that helps reduce friction. Because as the heart beats, the two layers are going to be rubbing against each other. You need to have a little bit of lubricating fluid. That's the pericardial fluid. Okay.
I have a question.
Mm-hmm.
You're talking about the chambers, the heart chambers,
Mm-hmm. Yeah. Which is right here, okay? Like if I have to finish drawing the chambers, that's the chamber.
Okay, you're talking about, okay, those are the outside part of it. Okay.
That's right. So this is all filled with blood. Is okay?
Yeah.
All right.
Excuse me, sir.
Yes, go ahead.
So these chambers are different from the walls.
That's right. The walls is just the outside, like what makes up the chambers, right? Okay.
Okay.
Like I like look here, right? Let's say this is the chamber, this is the hole in the middle. I'm talking about this thing, right? Like right here.
Okay.
You see? Okay. So like if this is filled with blood, where my finger is touching right now, that's the endocardium. Okay. This here, the outer part, that's the epicardium. And then this here, myocardium, okay?
Okay.
Now, if I wrap another thing around it, that's gonna be the pericardium, okay? The sac, right?
Okay, so thank you.
Okay, I know this is super confusing. I'm sorry I had to throw this at you, but don't worry. The question, I'm gonna show you the kind of question I'm gonna ask you, okay? But you know, let's try to talk about this one more time, okay? With the pericardium, I know it's confusing. So like I have a shirt on, right? Okay, let me go put on another shirt. Hold on. Okay, so now I am double layered, okay? This outer layer, okay, that's the outer layer. That's the parietal layer, okay? And then I have an inner layer, right? The inner layer is the visceral layer. You understand? The visceral is what's touching the organ, right? V for very close to the organ, right? Visceral, okay? And you see this space I'm sticking my hand in, right? Between my outer layer and the inner layer. What's filling up this space, guys?
The pericardial fluid.
The pericardial fluid. That's right, because as the heart beats, the two layers are rubbing against each other. We don't want that. We want to reduce the friction. That's why we have the pericardial fluid.
So, quick question.
Sure.
The epicardium and the visceral pericardium are the same thing, they just have different names.
That's right. That's the best way to think about it.
So, are they interchangeable or is there a context to use either one?
I mean, if I ask you what is the outermost layer of the heart, outermost layer of the heart wall, then you say epicardium. Okay. The inner layer of the pericardium would be the visceral pericardium. So that's kind of like the context. How should I put this? It's like this, guys. Again, like you don't have to know too much about this, but like it's like think about like a grilled cheese sandwich, okay? Like you have the bread and then you have the cheese, but then once the cheese is melted, it's like stuck to the bread, right? Like they are two separate things, but then they're stuck together afterwards. So that's kind of like what the epicardium and the visceral pericardium is like. Do you understand? It's like, you know, two things but fused together.
Okay, yeah, got it.
All
Thank
right.
you.
Yeah. Okay, let's keep going. 1 second. It's too hot with all these teaching. I gotta take off the hoodie. So everything I told you is written here. You can read it through yourself. Okay. Now, sometimes in addition to telling you, you know, the structures and the function, I will also tell you a little bit about what happens when they are not working properly. Right? So this is a normal pericardium. The pericardium can get infected and then it will become inflamed. Okay, so anytime you see itis, like hepatitis, right? Gingivitis, meningitis, pericarditis, right? Itis means inflammation. Okay, so this is the inflammation of the pericardium. People who experience pericarditis would often think they are having a heart attack because the pain is very, very sharp and it happens continuously. Every time the heart beats, it hurts. They call it like stabbing pain, right? And it's inflammation of the pericardium. Depending on what's causing the problem, if it's bacterial, then you have to go on antibiotics. Viruses can cause pericarditis too, but of course, if it's a viral infection, antibiotics is not going to do anything. All right, let's see what you have learned from me this morning. I am going to launch the poll. Okay, go ahead, choose the right answer. And hopefully you guys would participate more with the poll this semester. Okay, very good. All of you who answered this got it right. Let's try another one here. Okay, anyone else? Last call. Okay, good. Most of you got it right. The correct answer is closed two circuits. Okay, closed means the blood stays within the vessel, right? We want that. Right? We don't want blood to be, leaking all over the place. That's terrible. Okay, how about this? Last call. Okay, all of you got it right. Renal is kidney. It's in the table, but I just want to write it down for you. Pulmonary is lung. Hepatic. Anybody remember hepatic?
Liver.
Liver,
Liver, that's right. Hepatic, right? And carotid.
Heart.
brain, head.
Head. Yeah, head. That's right. Head. I think you're thinking about coronary, Tohib. That would
Yes.
be the heart. Yeah,
Yes.
that would be the heart. Okay. Carotid. Yeah. Feel the pulse.
You wrote heart and not
Oh,
head. I
sorry.
thought
Thank you. Thank you. Head. I was talking and writing at the same time. Yeah. Heart. Head. Carotid goes up to the head. Okay, very good. One more. Keyword here is muscle, okay? Muscle. Okay. The correct answer is the myocardium. Myo means muscle. Okay, you see myo something throughout the course. You know it's going to be muscle. Okay, so look here, right here in the middle. Myocardium, muscle. Okay, moving on. So, the heart. I already told you the heart has 4 chambers. We have 2 on the top. Can you guys actually see my mouse? Sometimes it doesn't show up, I was told. But can you see me when I'm pointing at things? Can you see it?
Yes.
Yes.
Yeah.
Yes.
Great, thank you. So on the top here, we have the right atrium and the left atrium. The top 2 chambers, it's called atrium. Okay? The plural for atrium is atria. Okay, so right atrium, left atrium, and you have 2 atria. Okay, it's weird. Like it's like you don't just add s. Okay, so just in case you read about it and you wonder what atria means, it's just the plural. So 2 atria on top, and then 2 ventricle. Ventricle, you can just add s. 2 ventricles at the bottom. Okay, that's fine. And remember, we're looking at this from the front. That's why the right side of the diagram is the left structure, and the left side of the diagram is the right structure. Okay, so you have the two atria on top, and they squeeze at the same time, and then the ventricles at the bottom will squeeze. Right, so when your heart beats, it's like squeeze, squeeze. Top squeeze first, and then the bottom squeeze. Right. Typically, we use blue to represent low oxygen content, and we use red to represent high oxygen content. So over here, the blue blood, that's low O2 blood. Okay, the blood is obviously not actually blue. Okay? And then over here, we have high O2 blood. Okay? Now, we don't want the blood to be mixing with each other. Okay, we don't want the low O2 blood to be mixing with the high O2 blood. So we have a wall that separates it. And that is called the septum, right here in the middle. Have you ever heard of people who are born with a hole in the heart? Okay, a hole in the heart? Yeah, that's the hole in the septum usually. Okay, so if there's a hole in the septum, then the blood would be mixing, right? And that's not good, right? Because then you're not distributing fully oxygenated blood in the body. Okay, so that could cause the baby to be a little bit bluish in color, in the skin tone, right? Because of that, but it can be fixed with surgery, okay? Depending on how seriously it is, of course. But the mild case can usually be fixed. They can close the hole up.
Excuse me.
Yeah.
How the heart work with a hole in the with a hole?
How does the heart work?
Yeah, it's I'm thinking about a speed, faster or lower.
Right. So we will talk about all that. We will talk about exactly how the blood goes through it, and how the speed changes and everything. So just hold on. We'll be there. Okay. All right. Let's go to our study guide, please. Let me move myself out of the way. And like I said, you need to have the study guide for the lecture. Okay, we're going to be using it quite a bit. Okay, so I want you to go to this diagram in the study guide. Okay, either have a digital version or, let me give you the link for the study guide. I will post it in the chat box if you need it. Okay. Now, for me, it's easier to just write the names right next to the structure. For you, you might want to put it in the box, okay, so that when you're studying, you can cover the answers up and then, recite it yourself, right? Do whatever you want, doesn't really matter. And so this is the heart, and we have cut the heart open. Do you remember from last semester? What cut is this? Is this a frontal cut, transverse cut, or is it a sagittal cut? Or have you given everything back to me after the exam? Oh boy. Okay, so this one, it's frontal, right? Frontal. It's like you take the plane and then you cut it this way. Okay, it's separated into front and back. Cut it like this. Okay, and we are looking at it from the front. So let's try to label some of these things. Okay, over here. What is that? That's one of the 4 chambers, and it's on the top. What should we label that as? Anyone?
Like the atrium?
That's
Right,
correct.
right
Maybe
atrium.
that the right atrium. That's very good. So that's number 4. That is the right atrium. Okay. And what number would represent the left atrium? Let's take a look at the diagram. What number? What's that again?
11.
Sorry? 11. That's right. Very good. Right here. Left atrium. Okay, so the atria, they contract together, they squeeze together, and the blood is going to go down. Right? What do we call the things that are below the atria?
Ventricle.
Ventricles.
That's right, the ventricles. And we have the right ventricle, that is number 7. And number 16 is the left ventricle. Okay. 4 chambers of the heart. You can label, you can like outline them if you want. Doesn't really matter. There we go. So on the right side, on the right side of the diagram, we have the blue blood, right, so to speak, the low oxygen content, and then on the left side, we have the high oxygen content. We don't want them to mix together, right? So what do we need? What do we call number 15?
The septum.
The septum is correct. So far, so good, I hope. Right? So that's the basic structures of the heart. Now, we have various blood vessels that are attached to the heart. Okay, we have vessels that are returning blood to the heart, which would be the veins, and we would have vessels that are taking blood away from the heart, and that would be the arteries. And so I want to label this one with you. I know it's a little bit difficult to color this one, but I haven't been able to find a better diagram that I like more so far. So we will have to just do this. So there it is. That's one vessel at the top. Okay. This one is called the superior. What does superior mean?
Above. High up.
Above, yeah, on top of. That's right. So this is superior vena cava. Okay, so if you think about the person, like a typical person here, the heart is going to be at this level, right? So the superior vena cava is going to be collecting blood from the top 1/3 of the body, from the top part of the body, if you would. Okay, that's the function of the superior vena cava. These are all in the notes. Okay, you can write down if you want, but I don't want to make the diagram too cluttered. And these are all in the PowerPoints. But just to explain to you, superior vena cava collects blood from the top part of the body. So remember, we were saying the jugular vein is collecting blood from the head. Well, the jugular vein will merge, will connect with the superior vena cava. And then the blood is going to go back to the heart. And you can see this is the opening of the superior vena cava. So when the blood comes in, it's going to drain into the right atrium. Okay? Now, you guys are smart people. There's a superior vena cava. So what do we think we're going to call this?
Number 8's the inferior vena cava.
That's right. Opposite of superior is inferior. Inferior vena cava, which would be collecting blood from the lower part of the body, right? Lower 2/3 roughly of the body. So these are bloods that are coming up from your kidneys, from your hepatic veins, okay? Things that are from the lower part of the body, and they will return to also the right atrium. Okay?
So the blood coming in from the inferior vena cava is deoxygenated?
That's right. They are low in oxygen content. It's not zero, but it's, it's low. Deoxygenated, yes. Okay, I'm gonna put an asterisk here. And again, this is one of those weird English things. Plural for vena cava is you add an E at the end. Okay, it's pronounced venae cavae. So you have 2 venae cavae. I mean, I don't really care. Like, you don't have to write anything for me anyways, okay? So, but then when you read it and you see an extra E and you're wondering why, that is why. It's particularly hard for those of us where English is not our first language. English is not my first language, right? So like, when I learned this for the first time, it didn't make sense to me. Like, why is there an extra E sometimes and not? So it turns out it's just plural and singular. Okay, I've been talking for an hour and 15 minutes. I'm sure you're a little bit tired as well. Why don't we take a break and we will come back at let's say 9:55, okay? 9:55. Okay, and then we will resume. See you guys in a bit. All right. Let's see what other vessels are connected to the heart. Right? So once the blood is collected from the superior and the inferior vena cava, they will go into the right atrium right here. Okay? And then the blood is going to go down to the right ventricle, and then they will be squeezed through this vessel. Right? So this one is going to go behind that and comes out right here. Okay? So this one, let me color it, is going to be called, actually, you might already know the answer. We learned the name already. You just kind of have to connect the concepts together. Anybody want to take a guess of what this yellow vessel is called?
Pulmonary?
That's right, the pulmonary. Right, so we have the pulmonary artery here. And it's separated into 2 parts here. So this is the left pulmonary artery. And then here it goes behind this thing, but it comes out here, and that's the right pulmonary artery. Okay. And this goes, it takes the blood to the left heart, left lung. And then this one will take it to the right lung. Okay. For reoxygenation, for picking up oxygen. Then it will return to the heart through the left pulmonary vein. Okay, so let's color those. Right here. Oops, can't see. Right there. They only show 2 on each side. Some people have 3 though. It's a genetic thing. So you can't really see it. You just have to take my word for it. They go behind. They go behind. You don't have to draw it on your diagram unless you want to. They go behind the heart. Okay, and then the blood's gonna come out like this. Okay. Is that okay? Does anybody have any question? All right. Then the blood is gonna go down to the left ventricle. And then it's gonna go up this final structure. Okay. It's gonna arch down, and then it's gonna go up like this as well. Okay. And this is the biggest artery in the body. Okay, right there. That is the aorta. Biggest blood vessels in the body, biggest artery. Okay. Now take a look at this, please. The aorta arches back and it actually goes behind the heart. Again, don't draw this, but try to follow me to visualize it. Actually goes down like this from behind the heart. And then it's going to come out here. Okay, so the blood will continue to come down. Right, this here, that's part of the aorta, okay? Okay, we say is the abdominal aorta. Okay. And then, can someone tell me what I'm drawing here? What is this black line that I'm drawing?
The diaphragm.
Diaphragm?
Yes, that's right. Very good. Okay, so there's a little opening in the diaphragm for this to go through. Okay. Now you don't have to draw the next part. I'm just trying to put things together for you to visualize. Okay, this is gonna continue to go down, and then it's gonna separate. Okay, into left and right, and then it's gonna go down more, and then that's where you're gonna have these things. What are those things?
Liver?
Kidney.
Kidney. Yeah.
Kidney.
Yeah, kidney. So 2 kidneys, right? The liver will be like right here. Okay, liver is right here. Okay, so everything is connected. Okay, and we're gonna learn all this in the whole course. Okay, you either feel excited about that, or you roll your eyes. It's like, oh, great. So the aorta also goes up, right? This goes to the left side of the body. This goes to the right side of the body. This is gonna go up to the head. The carotid artery, right? Takes it up to the head. Okay, but they each have their different names, but that's okay. We'll just leave it like that. Okay, I know there are still some labels that are missing. We are not there yet. We're gonna come back to it. I need to know if you have any questions for me. No, everybody's good? All right. Let's take a look at the PowerPoint again. These are everything that I told you about. You can read it, okay, compare it to the notes and try to understand it. All right, so let's move back a little bit. Okay, take a step back and try to understand this more. Okay? I already told you we have a closed 2-circuit circulatory system. Right, so let's put a name to these circuits. We have the pulmonary circuit and the systemic circuit. Okay. Pulmonary, you already know, means lungs. Systemic means bodily, okay? The whole body, essentially. It's easier for me to show you than to read it to you. So let's go back to our notes, which is right here. Okay, what happened? This is the wrong note. Oh, there we go. Okay, so you already have this. I hope you still have it. And I hope you made it big. I'm just gonna make it bigger there. So here, the heart is going to take the blood to the lungs, and the purpose is for reoxygenation. Okay, so we are gonna remove CO2 at the lungs. That's the waste product from cellular respiration, and we are going to add O2. And this circuit is called the pulmonary circuit. Okay, the purpose is to reoxygenate the blood. Right? So the blood goes from blue, again, figuratively speaking, to red. Okay. Deoxygenated blood is kind of like this brownish color, right? Brownish red color. If you ever buy like ground beef from the supermarket, sometimes you will notice like when you break it up, like the stuff that are in the middle, they are kind of like darkish, brownish, right? They don't look fresh, right? That's the deoxygenated portion. It's in the middle. They don't have exposure to the oxygen in the air. But if you leave it on the counter for a little bit, the oxygen actually goes in and it turns, pinkish color again. All right. Afterwards, from the heart, after the blood returns to the heart and it's full of oxygen, we can send it to the body now, right? What vessels should I put over here? What blood vessels? We just labeled the heart diagram. If you have it next to you, fantastic. Take a look at it. Tell me what vessel I should put over here. Just one. From the heart to the body.
Is it the inferior vena cava?
But inferior vena cava returns it to the heart, right? Isn't it? Yeah.
Aorta?
The aorta, that's correct. Aorta, right? Okay, the biggest vessel, right? And this is going to be pink because it's rich in O2. O2 rich. And then the other one, the blue one, is O2 poor. Okay. After it goes to the body, after we use the oxygen for our organs, we can return it to the heart. And that's where you have the vena cava, right? Superior and inferior. And then it goes back to the heart. This would be the systemic circuit. Okay. So in the body, you will add CO2 to the blood, right? We're talking about this from the perspective of the blood. And then you will remove O2 so that it can get into the body. Questions, anyone?
So in the beginning, you're adding the O2 and simultaneously you're removing the CO2, right?
Exactly, yeah.
And then at the end, it's the opposite.
I wouldn't say at the beginning or end because it's like, a cycle, right? But like I would say like at the lungs, you're doing this, and then at the body, you're doing that.
Okay, so at the lungs, you're adding O2 and removing CO2, and in the body, you're adding CO2 and removing O2.
That's right, from the blood, right? Yeah. So let's take.
In
Sure.
fact, pulmonary involve between heart and lung, and systematic circuit involve between body and heart.
And blood. Yes.
Yeah, blood.
Yeah. Good.
Thank you.
No problem. All right, let's take a look at this. Okay, so I know you cannot read the labels. That's not the point. You don't have to read this. You don't have to memorize any of these either. Okay, I'm just trying to show you what's going on to help you understand. So let me see where my pen is. Okay. Now this is superior vena cava, right? And then this is inferior vena cava. Right. So the blood will go into the right side of the heart, right atrium, right ventricle, and then it goes through the pulmonary artery, like that. And then you see at the lungs, it goes from blue to red, right? And then it goes back like that. Okay. So what I have in the picture there, this part, that's the pulmonary circuit. Okay. And then the blood is gonna go through the aorta. This is the aorta. You don't have to draw it. You can just try to watch me and see if you understand. The aorta, it's gonna take the blood up to the head and the upper limb, right? Okay. And that's where it goes from red to blue. You can see the arrow. The oxygen is leaving, and then the carbon dioxide is coming in. And then once you use up the oxygen, it's gonna go back to the heart. Right? Same thing over here. Right? We need oxygen everywhere in the body, in your intestines, right? In your liver, kidney, pelvic organs, lower limbs, all these locations, all these bodily locations, the blood is going to go from red to blue. Okay? As you are removing oxygen from it and you are adding CO2 to it. Okay. And I want you to understand that the two circuits, even though I show you like, one after the other, right? But in reality, it happens at the same time, right? You will never have a part of the blood vessel that's like empty, waiting for blood. There's always going to be blood in it. Okay, the whole thing is just cycling through the body. Okay, I got a question here. The idea that vein O2 per. Okay, so the question is that the idea that veins bring O2 poor blood and artery bring O2 rich blood is false. That's right. That's what I'm trying to say at the beginning, right? Some people think that vein always carries oxygen poor blood. That's not true. Okay, that's not what vein is defined as. Vein is just a vessel that takes blood to the heart, right? So the pulmonary vein, right, even though it's a vein, it actually contains O2 rich blood. Okay, so that's a good good question.
So I have a question. You said the blood vessels always have blood in them, right?
Yes.
Like they're never gonna be empty. So does that mean when the blood leaves the heart to go to the lungs, it's like through the right and left, it's at the same time. Like
exactly.
it doesn't go like to the right first and then to the left. It goes simultaneously.
Exactly. Yeah.
Okay.
Yeah, it's gonna make more sense as we explore more about the topic. Okay, as I show you more and more information, you will see, because the left and the right actually contracts at the same time, simultaneously. Okay. These are just pictures I took when I was in university. There was a course, it was anatomy, okay, that we take. But instead of labeling, you know, like these cartoon diagrams, I suppose, we had to label like actual organs. So this is like an actual heart, and we had a bell ringer test for each of the system. So they basically have like 40 stations around the classroom, and then they have these organs that are laid out, and then with a pin on it, and then they ask you questions about it. Like we have, I think, 2 minutes to answer the questions, and then the prof would ding the bell, and then we get up, and then we go to the next station. We cannot go back to, so it was like super stressful. So that's why I took all these pictures to help me study. So this was a human heart. And you know, all the blood has been drained and has been treated in a preservative formalin. That's why, you know, it's the color that it is. But the point is, you can see that the aorta here is pretty spacious. Okay, you can stick your thumb in there, and there will be a lot of wiggle room. It's the biggest vessel, right, in the heart. Next to it, you can see the pulmonary vein, which is substantially smaller, and you can see the pulmonary artery right here as well. Okay, so if you look back to your diagram here, is this it? Yeah, there it is. Right, you can see that the you know, the picture I was taking is like looking at it from above, right? Like looking at, like my eyes are here, right? As if, so like you see the aorta right here, and then the pulmonary artery, which is you know, right next to it. I guess you can't really see it in this picture, but anyway, that's what it is. And then over here, this is looking at it from the back, and I told my partner to put the fingers into the superior vena cava and the inferior vena cava, and it's actually the fingertips are actually touching inside the right atrium. Okay, because that's where the blood vessels are feeding the blood into, right? So here you have your aorta again, pulmonary artery, and all these gooey stuff. That's the fat. Okay. So I will only ask you to label, you know, cartoon diagrams to keep it simple. But, you know, I thought I'd show you that. Some of you might be interested. All right, moving on. Next, we have heart valves. Okay, heart valves. When it comes to circulation, when it comes to blood passing through the body, we want to make sure the blood is going in one direction only. Okay, we don't want the blood to be coming back, and that sometimes could happen. If the blood goes backwards, then we create these clash between blood that are going forward and then the blood that are coming back, and it creates turbulence, and it interrupts the flow of blood, and it could cause all kinds of problems. Okay, so we don't want the blood to move back, and to prevent that from happening, to prevent the backflow of blood, we need to have heart valves. Okay, heart valves. So there are 2 sets of valves. Each set has 2 valves in it, so total of 4 valves. We call them atrioventricular valves, or AV for short. As the name implies, it is between the atrium and the ventricles. So you have 2 AV valves, atrioventricular valves. And then the other group is called semilunar valves. The person who names them decided that they look like half moon. So semilunar valves. Let's go back to our diagram here, and we will label them. Okay. So I will use 2 sets of color here, right? So over here on the right side, this little white thing there, okay, that is the tricuspid valve. Okay, tricuspid valve. Cuspid means flaps, and tri means 3. So the valve that is on the right side, that separates the right atrium from the right ventricle, has 3 flaps on it. Okay, and these white lines that you see over here, those are little cords that pull them open when they need to open. Okay? We're not going to label them. Okay, so you have the tricuspid valve on the right side, and over here on the left side, okay, this one only has 2 cups, so we call it bicuspid valve. Now, I'm really sorry, but sometimes they have multiple names for the same thing. This one is also called a mitral valve. Okay.
I have
But
a question.
Yes, please.
Why the right side has a 3 valve and the left side has a 2 valve?
Yeah, like nobody really knows. It's appeared to be just the way that we are designed. Yeah, I don't have a good answer for that, but that's pretty much it. Again, nobody really knows why.
Just I'm thinking about need a more pressure in
Um,
the blood to body.
Not necessarily. I honestly have no idea. It shouldn't be the pressure though, because like if anything, the left side has higher pressure than the right side. So like you would expect to have like, I don't know, more flaps to make a good seal. I don't really know. If anyone finds out the answer to that, maybe yeah, you can share with the class. But there
Thanks.
thank you. We have the tricuspid valve on the right side, and the bicuspid valve, also known as the mitral valve, on the left side. So together, these are the AV valves, okay? AV valves. So what do? They prevent the blood from going back to the atrium. All right, so the tricuspid valve, listen carefully, the tricuspid valve prevents the blood from going back to the right atrium, whereas the bicuspid valve prevents the blood from going back to the left atrium. Okay, more on that later. Now
So
switch.
in a way, they're like one-way streets.
Exactly, they are, yeah, one-way street, definitely. Yeah. Let's choose a different color here. What have I not used? I don't know. Does yellow show up? It kind of shows. All right. So over here we have another one right at the entrance of the pulmonary artery. Okay, so we call that the pulmonary valve. Okay, sometimes folks they call it pulmonary semilunar valve, but it's okay. Pulmonary valve is fine. And then you have another one right at the entrance of the aorta. That's number 13. That's the aortic valve. And they belong to the same group, semilunar. Semilunar valve. All right. That's that. Are we okay?
I have a question.
Mm-hmm.
How much value of blood come in enter in the heart? And the first question, the second question, the same for other for export of blood from heart to body.
So
Inter and other.
the question is come again. What's you're asking about the valve and the blood?
Volume.
The
How much
volume, yes, volume of blood.
volume
Yeah, it depends. Okay, it depends, but you would be able to. It also depends on like what kind of physical activity you're doing, right? Okay, like sometimes you would need to have more blood that are coming out of the heart if you're exercising. Right? We actually have a slide coming up on that. So again, hold that thought.
but in the same inter and other
It's the same.
volume.
Same
Yeah.
volume.
Yeah.
It depends on the build of the person as well. Some people have a bigger heart and they would have a higher volume. Okay.
Oh.
Yeah.
Thank you.
No problem. Okay. So what is the function of the semilunar valve? They prevent the blood from going back into the ventricles. Okay. You can see the follow the arrows, right? Like the blood's gonna go through the valves and then into the pulmonary artery, and the valve would stop them from leaking back. Same thing on the left side. Okay, so that's all the labels. Okay, that's all the labels. Now I want to do this with you to help you understand more. Okay, let's go back to our notes, and we're gonna trace a drop of blood. Okay, again, I hope you have colors with you. Okay, I hope you have colors with you. Ideally, you would have black, right? Red and blue for this one, and then 2 additional highlighters or something. Okay, now this is a cycle, so really there is no beginning or end, but typically people like to start with the heart, with the heart, and it doesn't really matter which part we started, but let's go with the heart. And from the heart, actually, you know what? Sorry, I got distracted. Let's start at a specific part of the heart. Let's start with the right atrium. Okay, right atrium. We are following the blood. So from the right atrium, we are going to go into the right ventricle, right? From right atrium to the right ventricle. It would also help if you have the diagram that we just labeled, and then you can trace along with me. And it has to go through a valve, right? What valve do we go through to go from right atrium to right ventricle? What's the name of the valve?
Superior vena cava?
That's a vessel, right? I need a valve.
Aortic valve.
Tricuspid. Tricuspid.
Okay, yeah.
Tricuspid valve.
We have several different answers here, so let's just go through it one more time, just to be safe. Okay. Okay, so again, if you have the diagram, please put it right next to you. We start with the right atrium right here. The blood is gonna go to the right ventricle, right? And the valve that we pass through is this orange one right here. That's the tricuspid valve. Okay? So follow along the diagram. Tricuspid. Where are we? Let's see. So I'm going to put it right here. Tricuspid. Okay. From the right ventricle, we're going to send the blood to the lungs. Going to squeeze and push the blood to the lungs. And so the vessel that takes it to the lungs, pulmonary artery. But there is also a valve at the beginning of the pulmonary artery, right? And what's the name of that valve?
Pulmonary valve.
Pulmonary valve. That's right. Pulmonary. And it's going to go to the lungs for reoxygenation. Okay. Oxygen is going to come into the blood. Carbon dioxide is going to leave. when we are finished exchanging gas, then the blood will go through the pulmonary vein, which would take the blood back to the left atrium, right? I'm just gonna pause for a second. I want you to be able to trace this out on the diagram and make sure that we didn't miss anything. From the left atrium, we are going to let the blood drop down to the left ventricle. And what kind of valve? What's the name of the valve that we have to go through?
Bicuspid valve.
Bicuspid valve. That's right. Very good. Bicuspid. Two flaps, right? Like a bicycle has two wheels. From the left ventricle, we will squeeze the blood through the largest blood vessels so that it could send it to the head, to the left side and the right side of the body, as well as the bottom of the body. But at the beginning of the aorta, we have an other valve, right?
Aortic valve.
The aortic valve. Thank you. And then it will go to the body, where the oxygen leaves the blood, carbon dioxide comes in, totally running out of space here. And then when it's all said and done, we will take the blood back to the right atrium through the superior and inferior vena cava. Okay. If you have a highlighter, you can highlight with me. Oxygen poor, oxygen poor, oxygen poor, until we get to the lungs, where it gets reoxygenated, right? And then everything is oxygenated afterwards until it gets the body, like that. Okay, so once again, remove CO2, add O2. Remove O2, add CO2. Okay? I'm gonna highlight this one here and this one. What should we call them? What should we call the yellow stuff?
Antivascular valve. Atriovascular valves.
Yes, we are close. Yeah, atrioventricular valve, right? Okay, it's semilunar is the other one. Okay, so this is AV valve. We can say AV valve for short. And then the these ones, that would be semilunar. Okay, and just to complete it, O2 poor, O2 rich. Okay, so this diagram summarizes everything we learned so far. Most of the stuff that we learned so far. Now, I will show you how to use this. If I ask you, what is the purpose of the tricuspid valve? Listen carefully, okay? Stop copying, just listen for a second. What is the purpose of a tricuspid valve? You look at the thing, you look at the structure that's before it. So in this case, it's right atrium. Right? So tricuspid valve prevents backflow of blood to the right atrium. Pulmonary valve prevents backflow of blood to the right ventricle. Bicuspid valve prevents backflow of blood to the left atrium, and so on and so forth. All right? So this is very important diagram. You should practice drawing it on your own. Okay, put it on your summary sheet when you do the test, do the quiz. It's going to be useful. Okay. So that's just basically what I've been trying to tell you. Right, we have tricuspid on the right side, and then the bicuspid on the left side, and then it tells you what it does. And then the pulmonary and the aortic valves. Okay. I know on our diagram the aortic valve is like more like further down here. It doesn't really matter. Like the point is that it's in the aorta. Okay. Now, take a look at the next two slides here. This is a transverse cut, and we're looking at it from the top. Okay, so we can see the right side and the left side here. So I mean, you can't really see it when they're open, but let's take a look at when they're closed. Okay, so you can see 1, 2, 3 flaps, right? That's the tricuspid valve. Only 2 flaps here. That's the bicuspid valve. Right. So the thing is this: the tricuspid and bicuspid, they belong to the same category. They are the same group, which means they will open and closes simultaneously at the same time. Okay, when the tricuspid open, the bicuspid will also open, and then they will close together. Same thing with the semiluna. Okay? Semilunas will open and close at the same time. But the two groups, the AV and the semiluna, they will be out of sync. They are in sync with their same group, but out of sync with the other group. So you can see in this picture, when the AV valves are open, the semiluna are closed. When it's time for the semiluna to open, the AV valves are closed. Okay, so I want you to understand that. Okay, so what exactly is happening here? Remember, the heart goes like this. Squeeze and then squeeze. Atria will squeeze first, and then the ventricles will squeeze afterwards. When the atria squeeze, the blood is going to go down to the ventricles. Right? When the atria squeeze, it doesn't have to squeeze very hard, right? It's just a gentle squeeze, and then gravity will do most of the work. The blood will come down, and it will fill up the ventricles. Right? It is important to close the exit, so to speak, to close the exit while the ventricles are filling up. Well, what are the exit points, right? On the right side, the right ventricle is going to basically send the blood through the pulmonary artery. But on the left side, it is going to send it through the aortic valve, the aorta, right? Let me show you what I'm talking about here. That's why it's hard to.
Excuse me, I have a question. How many kind of muscle there's in heart?
Just the cardiac muscle. Yeah, just the cardiac muscle, just one kind. It's involuntary, right? You cannot control it, right? Okay, so take a look at here. You don't have to draw anything. Just look here. This is the right side, right? The right atrium, right ventricle, and then oh my goodness, it's going all over the place. Try it one more time. Right. This is the right ventricle, and then it's gonna send the blood to the lungs through the pulmonary artery, right? But on the other side, it's gonna send the blood to the aorta. Right? So these are like the exit points. That's what I mean. Now, as the blood is filling up, like that, we don't want the blood to prematurely enter the blood vessels. We don't want to empty the ventricles before they are filled up. That's why you have to close the exit. That's why you have to close the exit point. And that's the reason why you have to leave the pulmonary valve and the aortic valve shut as the blood is filling the ventricle. Okay? So one more time. When the atria squeeze gently, the tricuspid and the bicuspid will open to allow the blood to go down to the ventricles. And as the ventricle is filling up, you don't want the blood to be escaping. Okay? So you close the pulmonary valve and you close the aortic valve. Once the ventricles are filled up, it's time for the ventricle to squeeze. When the ventricle squeeze, on the right side, you want the blood to go to the pulmonary artery. And on the left side, you want it to go through the aorta. But you don't want the blood to go back to your atrium, right? So that's why you have to close the tricuspid and the bicuspid valve so that the blood can only go forward and not backwards. Does that make sense? You guys have any follow-up questions?
That's good.
Yeah, okay. Great. All right, let's see. It's always good to do some poll questions. Go for it. Supply blood means like send blood to it, right? Okay, anyone else? Okay, most of you got it right. The correct answer is the superior and inferior vena cava. If you're confused, all you have to do is look at the diagram we drew, and you look at what's before the right atrium, right? Here is the atrium, right atrium. What's supplying blood to it? What's the thing before it? Superior and inferior vena cava. And what's supplying blood to the pulmonary artery? Well, it's going to be the right atrium. It's always the thing that's before it that you are supplying the blood to. Okay, next one. Okay, a couple more seconds in case anyone else want to try. If you have the diagram, you just look for things that are red, right? Pink, right? As opposed to blue. And the correct answer is pulmonary vein. Pulmonary vein, it's just coming back from the lungs. So of course, it's going to be rich in oxygen. Again, just take a look at this. Okay, just look at all the structure. Anything that's colored blue, that's oxygen poor. Anything that's pink, that's oxygen rich. Okay, that's why I said this diagram is important. It will help you answer some of these questions. Another question. Prevents backflow of blood to the left atrium. The correct answer is the bicuspid valve. Okay. Prevents backflow of blood to the left atrium. So you go back to our diagram here. Left atrium is right here. Okay. So what prevents blood from going back to it? Well, it's the bicuspid valve. Okay. Bicuspid valve. The valve prevents blood from going to the previous structure, right? So that's that. All right. Moving on. The next thing we're gonna learn is heart sound. Right? You know, people can listen to the heartbeat using a stethoscope. Of course, stethoscope can be used to listen to, you know, breathing as well. But people often describe the heart sound as lub and dub, right? Those are the two sounds that can be picked up using a stethoscope. But if you use instruments, you can pick up additional subtle sound as well. But basically, the first sound, the lub, is caused by the closing of the AV valves. So when the tricuspid and bicuspid valve, they close, that creates a sound. It's like, you know, slamming a door shut. It creates a sound, right? And the second sound is caused by the closing of the semilunar valves. So those are the two major sounds that should that should be able to pick up by the stethoscope. If there are additional sound that the physician hears, the doctor hears, we call that heart murmurs. Okay. Murmur in English is like, you know, if someone is like making these like mumbling sound like that, right? That's murmuring. Okay. So when you say heart murmur, it's talking about these additional sound that are often created as a result of turbulence in the blood flow. Remember, blood is supposed to go one way, right? So like if blood is coming back and they're clashing against each other, then it's going to create these turbulence. Okay. What do you mean by which one is louder?
Which one is louder?
Oh, you mean the first sound or the second sound? Typically, typically the first sound is louder. Yeah.
Louder. Thank you.
So, where was I? Right. So the turbulence, right? Okay. So these are gonna create additional sound, extra sound. So what's responsible for these turbulent flow? Well, here are some examples. Okay, first one is called regurgitation. Okay? Regurgitation, and that is caused by leaky valves. Okay, leaky valves.
Excuse
Now,
me, sir.
yeah.
Does humans regurgitate? I think animals regurgitate.
Sorry, one more time again.
Like, does human regurgitate?
Okay, yeah. So I understand what you're saying. Regurgitation can mean like throwing up as well, right? Is that what you mean? Like when
Yes.
you barf? Yeah, but
Yes.
that's a different context. Okay, in this case, the heart murmur. When we say regurgitation, we are talking about the blood regurgitating. Not like you're vomiting blood, but the blood is shooting backwards. That's what it means in this context. Okay. So let's take a look at this diagram. We have a tricuspid valve here. Okay, that is supposed to close. So when the blood goes forward, right, it will only go forward. It cannot come back up this way. But it's possible for people to be born with a leaky valve. So when the valve doesn't close properly, when the ventricle squeeze, some of it will go forward to the pulmonary artery, but then some will also regurgitate. It goes backwards. Okay, and that's going to mix with the blood that's coming into the right atrium, and that creates turbulence. Okay, so people who are born with it, we call that congenital heart defects. It's also possible for people to have leaky valves because of inflammation, right, of the endocardium. We call it endocarditis. Bacterial infection, for example, it causes the valve to swell up, and then once they are swollen, they don't close properly, okay, and then it regurgitates. Okay, so that's regurgitation. It basically means the blood is leaking, and the valves are leaking, and the blood is going back. Number two is stenosis. Stenosis means narrowing of vessels. Okay, so sometimes the blood vessels can narrow for various reasons. Okay, maybe there is a lot of buildup of cholesterols, right? Of fatty substance that makes it narrow, and then the when blood goes through a narrow vessels, it creates these turbulence, which might or might not be able to picked up by the stethoscope, and we call it heart murmur. And then finally, we have something called the cardiac shunt. Okay, a shunt is a connection between two structures in the body. Okay, connection between two structures in the body that are normally not connected. Okay, so we have a cardiac shunt. I'll show you an example of that. Okay, so just to backtrack a little bit, what are we talking about? Normally, there are two heart sounds, right? The lub and the dub. Right? That's normal. If there are extra sound, we say heart murmur. Okay, the murmur can be caused by leaky valves, could be caused by narrowing blood vessels, or it could be caused by a shunt, which I'll show you what it is. Okay, some murmurs are nothing to worry about. We call those innocent murmur. Some murmurs are cause for concerns and needs to be, there more testing needs to be done to see whether a treatment is needed. Okay. When the baby is in the mother, still growing in the mother, there is no need for the baby's blood to go through the baby's lungs, right? There's no need for the baby's blood to go through the baby's lungs when the baby is still inside the mother, because the mother is breathing on behalf of the baby, right? The baby is getting the oxygen from the umbilical cord. Okay, so there is a structure that's called the ductus arteriosus. You don't have to memorize this. I'm just telling you or intrinsic, okay? Ductus arteriosus. Okay? That allows the blood to bypass the lungs. What is this artery right here? This one right here. Can you tell me, please? I hope you know. This one that I just draw the arrow in. Which blood vessel is that?
Pulmonary.
Pulmonary artery, that's right. Okay, pulmonary artery. So that's supposed to go to the lungs, right? But for the fetus, we don't need to take it to the lungs because the lungs are not like, breathing oxygen. So there is a shortcut called the ductus arteriosus in the baby, in the fetus, I should say, that allows the blood to skip the lungs and just go directly to the aorta. Okay. So that, creates some, efficiency, right? You don't have to go to the lungs because there's no point in going in. Let's just skip directly through the to the aorta.
So
However,
is it like a little door? Sorry.
Sorry, say that one more time.
Is there like a little door, or how does it just skip it?
Oh, it has a little tube, okay, little tunnel, okay, little tunnel, extra vessel that connects the pulmonary artery to the aorta. Okay, so that's why it's called a shunt, right? A shunt is a connection between two parts of the body that are normally not connected. Okay. Now, as soon as the baby is born, like out of the mother, right? Then it needs to breathe on its own. So this thing is going to close as soon as the baby is born. It needs to close. If it doesn't close, then the blood is like some blood is still bypassing the lungs, and the baby would not be able to get enough oxygen, right? Okay. So that's what's supposed to happen normally. In some cases, though, it doesn't close fast enough. It's supposed to close like pretty quickly, but in some cases they don't close quick enough. And sometimes they don't close at all. And that's gonna be a problem for the baby. Baby's not gonna be able to get enough oxygen, right? Okay, they might have low O2 content. And then, if still after a couple of days it doesn't close on their own, then intervention is needed. So that's why it's one of the first thing that the doctor check for when the baby comes out. Actually, the nurse does this usually. When the baby comes out, is they have to listen to the heart, okay, and check for murmurs and see if there is any abnormalities with the sound, right? And if there is, then they need to do chest ultrasound right away, right, to see if this is one of the cause or if there's other problem that is happening. So when my second daughter was born, the nurse was listening to the heart, and I was standing right next to her, and then I heard her said to the other nurse, it's like, "Oh, there is a murmur," and then immediately my heart sank, and I looked at her, and she's like, "Oh, don't worry, we'll get it checked out." And so she did the whole ultrasound and everything, and unfortunately, it was an innocent murmur, okay, and it just resolved on its own. And the doctor afterwards was saying it's probably because of the ductus arteriosus that it didn't close quick enough. And that's why they picked it up on the stethoscope. Okay, so sometimes it's things like that. Other times it's more serious, right? Maybe it's a congenital valve problem. Maybe the baby is born with a defective valve, and that of course is much more serious and it requires intervention. Okay, so heart murmur. Okay, last thing I'm gonna go through with you. This is the wrong label. This should say heart rate. So heart rate is also called the pulse, but what's causing the pulse is something entirely different, which we'll talk about. But when you take the pulse, right, you're basically trying to measure the beats per minute. Okay, how many times does the heart beat every minute? It depends on the person, okay, like 72 to 80 beats per minute. But if you're physically fit, your resting heart rate could be as low as 60. Okay, it depends on whether you're standing or sitting or whether you are stressed out. It depends on a lot of things. Okay, so it's a wide range, but that's the typical heart rate. And then there's something called the stroke volume. The stroke volume is the volume of blood that's being pumped out, being ejected from the ventricle per squeeze. Okay. Someone was asking earlier, right? Like what's the volume of blood that's pumping out from the heart, right? 60 to 80 milliliters per beat. That could change again depending on your physical need at the moment, and it depends on other things like did the person suffer from a heart attack? Is the muscle weaker now, right? So on and so forth. So that's the stroke volume. And with these two information, and you need to know this formula, okay? We can calculate something called the cardiac output. Okay, Madison, can you see the stuff if I write down here? Or like other people, like, is okay? Not okay?
Most of it. Okay.
Yeah. Okay, so cardiac output equals to heart rate multiplied by stroke volume. Okay, so let's do an example. Let's say someone has a heart rate of 70 beats per minute. Multiply by the stroke volume. Let's say stroke volume is 60 milliliters per beat. Okay, BB asks, is heart rate the same as blood pressure? Nope, heart rate is how fast your heart is beating. Blood pressure is how much force is the blood pushing on your vessels, which we'll talk about later on. Okay, so 70 beats per minute times 60 milliliters per beat. A little bit of math here. We can cross out the beats. Think of it as like fractions. 70 times 60 is 4200 milliliters per minute. Okay, or there are 1,000 milliliters in a liter, right? So we can put 4.2 liters per minute. Okay, so this is the cardiac output. Basically, how much blood is being circulated in the body every minute. Okay, and we can use this information to assess various things about the person. Okay, like is the heart doing well after surgery, for example? Okay, is the athlete increasing the blood circulation as he or she is doing more training? Right, so various information we can get from this. But I want you to understand this is not a fixed number. Okay, your cardiac output will change depending on what you're doing. Okay, if your heart rate goes up, then of course your cardiac output is going to go up as well. Okay, if your stroke volume changes, that's going to also change your cardiac output. Okay, so it's not a fixed number. All right. So you should know this formula. You should know how to do the calculations. You should also know the unit associated with each of the things in the formula. And that takes us to 11 o'clock. Okay? I think we'll stop right there. We will finish as much as we can. We should be able to finish next class on the cardiovascular system. What you do want to do between now and next class is, of course, organize your notes, but also work on your study guide. It's very important that you do. Okay, I'll post the answer, but try doing some of these questions. Right? This is just straight from the PowerPoint. You can copy it. This is the pathway. Right? Some of the questions you cannot do yet. We haven't learned it, but most of them. Do as much as you can. And I'll see you again on Wednesday. Okay, check the eCentennial though. Later on today, I'll post a link to where you can find the recordings and the class notes and stuff like that. Yeah, that's it. Thank you for coming. I'll see you all on Wednesday. Enjoy the rest of your day. Bye for now.
Bye. Thank you, Professor. Bye.
Bye.
I have a question.
Thank you, sir. Thank you,
Yeah,
sir.
go ahead.
This is my first time taking the online class. Is it any possibility before the